Hello, good morning. Thank you for having me here. My name is Sofia Badini. I am a PhD candidate at the University of Wageningen in the Netherlands. And today I'm presenting my paper, Information Frictions of Confidence in Learning, Experimental Evidence from Floodplain. So, if there's one thing that I learned in the past 2 years of PhD is that there's a lot of information online on areas around the globe which are exposed to flood risk. So floods are very well-mapped disasters. So these are intended for different purposes. So some are really from researchers for researchers, but most are funded by governments. So there's public money going into developing it, and they're supposed to improve decision-making at different levels of society. And in particular, some are really meant to be used by homeowners, or at least people who live in flood-prone areas, in particular the FEMA one, but also the flood maps that I use in this paper, which are developed by the Dutch government. They're over here, and you can really search them by address. You can put your address and you're gonna see the risk profile of your address. And indeed, there's a lot of evidence of limited adaptation to floods, even if floods are very expensive. They're the most expensive natural disasters. And we know that, for instance, we don't have a lot of infrastructure for flood protection, and the insurance take-up remains quite low, and it seems like flood risk is also not fully capitalized in property values. So then, in principle, it makes sense to improve information on this topic, but then the question is, does it work? And of course, it's really difficult empirically to assess whether this information are used, because usually they're rolled out at the same time. You can't observe the users. And there is some evidence, actually, some clever empirical studies are exploiting difference in timing or in the spatial deployment of these maps. And it looks like actually people fail to appreciate information on flood risk. And there's a much broader literature showing that people fail to appreciate public available information in all sorts of other topics like health and energy consumption and climate policies. So then this entire project started by asking questions on kind of the design of information intervention for the disclosure of environmental risk in particular. So is offering information sufficient to change beliefs or behavior? So is this really about costs? Because who would know where to start to look for information on this? But also, can public policy helps in the sense of making certain pieces of information more visible than others? Because then my reasoning was, even if maybe search costs, of course, they play a role, but then it could also be that people don't know what they don't know. And this could also become a bigger problem with climate change, because then areas which have not been at risk until now, they may become at risk. And then this makes harder for people to learn that there's something that they should learn. So how do I address this question? With an experiment. So I do a survey, an online experiment, which is embedded in a large-scale survey, which is targeted at floodplain residents in the south of the Netherlands. The design has 4 treatment arms. The variation is not coming from giving people different information, but by prompting people to read different texts, which are on, so there's a neutral text that I'm gonna go back to later, but there's a text on information on risk profile and people's address based on public available flood maps. One is on rule on government compensation, and one is on the functioning of the insurance market. And in principle, everybody can read everything. So the outcomes, there's 2. One is willingness to pay for insurance. This is a hypothetical measure. So to have some robustness measure that could be a bit more informative on how people would behave, I have a robustness measure on willingness to pay for information on companies offering insurance in the areas. And this is incentivized with a multiple price list version of the BDM method. People ask, would you like more information or would you like more money, because the service is incentivized probabilistically. And then one scenario is selected, and then whatever people choose, they're gonna be shown information or given more money. And then here I had a very specific kind of story in mind, where you give people information, they will update their beliefs. This is going to be reflected to willingness to pay for insurance. So then I have like hypothesized mechanism on belief updating. So these were supposed to be like proxy measures for expected damages in each period. So there's a perception of risk, perception of damages, government compensation, and then I have a catch-all measure of water, just to see. All outcomes and mechanisms were all pre-registered, and I'm controlling for all these hypotheses across all the treatment arms. So it's 21 pre-registered hypotheses, and I'm controlling for post discovery rate. So before telling you exactly what the design looked like, I'm going to tell you why the Netherlands is such a, okay, first the contribution to literature. So I'm contributing to, I would say, 3 strands of literature, which is largely overlapping. So one is how people learn about their flood exposure, and then here I have direct individual level evidence. And usually you have empirical studies which are seeing that, they are using difference in different studies, looking at before and after flood maps were released, or people were exposed to floods in the first place. And instead here I have really individual level evidence on how the entire learning process works. But also I'm contributing to the literature on effectiveness of informational campaigns on flood risk, more broadly disclosure of environmental risk, and I have something to say about the design of these interventions, which again, existing study tend to look at already implemented interventions by the government, for instance, and also even more broadly, new evidence on information choice and belief formation in a very specific context, which is low probability, high stake events. Now, what I wanted to do before, I'm going to tell you why this is a great setting actually for an information provision experiment. So this is the Netherlands, we are here. And this is the Netherlands, and the blue area, it's all the floodable area. It's 60% of the country and 2/3 of the people live in it. This is my study area, which is in the south. And there's actually a crucial difference between most of the Netherlands and this area. So here, flood risk is from the North Sea. So there's very limited potential for individual adaptation. And the government actually invested a lot of money in the Delta project, the Delta Works, which is like massive system of dikes and infrastructure, because basically the country was nearly destroyed in 1954 after massive floods from the North Sea. But then here, floods are from rivers. And then, first of all, there's strict engineering limits on how much infrastructure you can build because there's just no space. But also this is not the economic core of the country. So it's also very difficult to kind of, from a public acceptability perspective to invest even more in infrastructure here. So then it makes a lot of sense to push people to do more private adaptation, including insurance. More reasons why this is a really good setting. So information quality is amazing. So there's flood maps at the street level with a different level of inundation for different kind of magnitude of events. So 1 in 100-year flood, 1 in 1,000, 1 in 10,000. And also there's specific information on the maximum water level in case of a flood in categories. And it can go up to 5 meters. And government compensation in case of a flood is uncertain. So it's a political decision whether to compensate people. And the flood insurance market is private and voluntary. And actually many insurance companies expanded coverage, particularly for riverine floods in the past few years. And also flood risk is really a salient topic. Like it's ever in the news, it's historically like a big threat to security in the country. And also there's been a recent major flooding in the area of study in 2021. So just when I started my PhD. Yes.
Do you have information on how your study participants were affected by it? We have a lot of evidence of this kind of
Yes.
very short-lived behavioral decisions over insurance purchase based on research.
Actually, yes. So I'll be back to this in a second. I also have information on flood exposure. It doesn't really matter for this paper, but I do have that. And I also know that it was
Doesn't matter empirically.
Not for information acquisition and belief formation. I can see that at baseline they have different beliefs, but it doesn't matter specifically for the research question in this paper. Also, the area is very small, so pretty much everybody got flooded or were close to flooded areas. But now the design, so that you see actually what I did. So there's the important section basically in this graph. So the first is the things that I asked before the experimental section. There's a section on household demographics, so I know a bit of who these people are. And then there's a section on elicitation of beliefs. And I have 2 kinds of beliefs. Some are objective, so they can be checked against publicly available information. I know if they're wrong or right. And some are subjective. So for instance, risk perception or also expectation on government compensation. And that's quite different because if somebody doesn't know the law and thinks that the government automatically triggers these calamities and compensation, I think is of a flood, that's wrong. But if somebody tells me I expect the government to pay me back 80% of my damages, there's no way that I can assess whether that's reasonable or not. Afterwards, there's the experimental section. So I have 4 treatment arms. People are assigned to have equal probability. So first, people are asked to read the text. The neutral one, there's no such thing as a neutral text, but this is a nice one on nature conservation around flood rivers in the Netherlands. So like if the main effect is through informational content, this is supposed to kind of like wanted to read more. So it was like the idea was to have a text that would make the effect more conservative. And then again, risk profile. So the probability with which your address floods and what's the maximum water level is going to be. Government compensation. It's on rules and laws and regulations, and the functioning of the insurance market tells you which damages can be insured or not. Then afterwards, people are told that if they want, they're going to be given other text. These are contained in collapsible boxes, which are closed. And they're told, if you want, you can skip to the next part of the survey. Otherwise, you can read this text, but we won't ask you questions because they were assigned for feedback to survey participants. And the entire study is framed as improving public communication on flood risk in the Netherlands, which is not false. So I can see when these collapsible boxes are open, and I can also track how long people are spending on it. Then afterwards, we elicit the subjective beliefs that are my main mechanism, and I have the two tasks, the willingness to pay, elicitation. Any question? Good. Now, how do I recruit the sample? By myself. So there's an enormous database in the Netherlands, which contains all the geolocated addresses in the country. It's a small country, so they can manage to do this. So I merged this to national flood maps and to data on flooded areas in 2021. So I have really flooded areas taken by aerial images straight after the floods, but also I got the postcode with submitted claims from the government. So then for every address, I know their flood risk profile and then whether they were flooded or not. And then I'm oversampling in flooded areas because I did think that this would make a difference experience, but then I think really the area is so small that it doesn't really matter. And I'm only including houses because apartments have several floors and I don't know where people are residing. So then it's a very specific kind of target population. And then people are reached by postcard at their address. So who are the survey respondents? Very special people. So I'm not claiming representative in any way. So I have, the response rate is very low, which is 5%, which is not surprising because I'm not using a conventional vendor or an existing panel, but it's still enough for internal validity. Basically, I have enough observation to have some decent power. So the risk categories, according to flood maps, they're not very different from target populations. It doesn't seem that there's systematic bias, at least across space. The sample characteristic, I think they're very interesting because these are people who care. So the survey participation was incentivized, but the Netherlands is a very rich country, so it doesn't make a lot of sense if you promise people money. So these are people who care about this topic. 90% are homeowners. They've been living here for a long time, and also they don't plan to leave anytime soon. They don't want to move. They don't want to sell their house. So they're very educated. So 75% have some form of university education, but it doesn't look like their like income is really matching this high educational profile because only 1/3 of people have more than 4,000 euros per month. And in the Netherlands, most households are 2 people. So this is not a lot for the Netherlands. And interesting, only 5% report having insurance. So, yeah. That would be a study to improve communication on flood and natural management in the Netherlands. No, sorry, on water and nature management.
Nothing about your own situation, right?
Yeah, I didn't want a super biased sample, but then in practice, I got very specific people.
And what's the treatment compliance like today, actually, because you have the timing for that.
Yes, I have a full slide on that. I'll be back to this in a second.
Complex question. What's the regulatory environment around insurance? There's no sort of NFIP.
Nope, it's all private. And there's been
private and voluntary, and only 5% of people take that up.
Yes. So actually, this is smaller than what the National Association of Insurance say that market penetration is, because they say it's up to 50%, but they recognize there's a lot of heterogeneity. And also the National Association of Insurance is a voluntary association, so most of the companies are not sharing very disaggregated data. So actually, like we were kind of in touch with them, and they did tell me it's not that crazy that the market penetration is so low, because Limburg is historically a pretty politically data collection place, so they don't really trust the government, they don't really trust insurance companies. This is actually coming back later. So it's very, yeah, it's completely private.
What happens if you get flooded? Does the government do anything?
It depends. So in principle, uninsurable, like damages which are not insurable should be compensated. Then in practice, after the flood in 2021, people didn't know that they were not insured. And then they really tended to weaponize this ignorance like it was your problem. So the government paid only 50% of the submitted claims that they received. So this actually is very relevant for later, because I don't think that this works through learning, through informational content, which I expected to work through that channel, because actually beliefs and confidence in beliefs are very heterogeneous. So they take all possible values that I'm giving them, basically. And information quality is quite poor, and yet respondents are pretty confident in their guesses. So it looks like this, like 80% of the people are giving 4 or more incorrect responses to these like information-based questions, but then the confidence is pretty high. And more specifically, respondents tend to overestimate the category flood probability, except the 1 in 100 years floodplain residents. So this is mechanic. Everybody thinks they're in the 1 in 100 years floodplain. So basically the 1 in 100 years floodplain residents, like for real, they're either right or they are underestimating their category. But pretty much everybody underestimates their maximum water depth. They all think they're going to be flooded up to 50 centimeters. And instead that's true for like 30% of the sample.
What would be uninsurable?
The damages from floods from the North Sea or major rivers. So like the Rhine is not insurable, and unless you're really, really rich, and then maybe there's gonna be insurance companies making exceptions for you. But like the rivers from floods from secondary rivers, they can be insured, and many companies are actually offering that.
And the government will pay.
Not really. I mean, it's all a political choice, so they can decide to do that. But in principle, there's no there's no rule that forces the government to pay. So compliance. They took this survey at home. There was no reason why to finish it in the first place. And actually I see that under control when basically learning is fully driven by selection. They're not asked to read anything. 1/3 of participants read nothing. And it's not the one that have the best information quality. And actually they seem to, like most people seem to skim through the text, because I see that the median participant is spending 26 seconds on a text, and it should take 45 to actually read it, according to average touch speed. But then when they're asked to read the text, so on the extensive margin, it really goes from like, I think in every text, there's 50% to 65% of people reading at all. And then the experimental treatment, it really at the expensive margin, it goes to 100% by design, but then they're also spending more time. So it's 50% to 65% more. So it's really pushing them on the other side. I know that they read this text, at least the median participant. And all the fun actually is happening under this risk profile treatment, where people are asked to read the risk at their address. So 50% of participants, they don't read anything else afterward. And I thought that this would be the people who found out that they are safe, that they were severely overestimating their category. But no, so it's not correlated to that at all. It seems fairly random at this stage who stops reading. How do participants update? Very chaotically. So belief updating is not different on average across treatment arms. I'm not claiming there's nothing, I'm claiming it's very noisy. So the standard there is very large. And so this is, the results are consistent depending on model specification, which include more and more covariates, basically. But also again, I'm adjusting everything. For false discovery rate, actually all these results are consistent to using the Bonferroni correction, like the crazy stable. So again, I wouldn't say that there's nothing, like they're moving a bit in the direction where you would expect them to move. So after insurance, total compensation goes up, but it's not conclusive, I would say, when the measure of water is not conclusive. And I think there's so much noise because most people don't update at all. So for water and damages, like 80% of people don't update. And for flood probability, this is a measure which is also more correlated with willingness to pay for insurance across all treatment arms. About half people update, but they do in both directions. So then the beliefs do not converge to probabilities implied by flood maps. It looks like this. So very chaotic updating. But then this is the main shocking results. I see this. So this is risk profile. There's a drop in willingness to pay for insurance, the hypothetical measure, compared to baseline. It only happens here. It's extremely robust. So to model specification and multiple hypothesis testing again, but also robust to handling of outliers. It's not attrition. Estimates have actually the same direction and the same effect size when using willingness to pay for information, but that is not significant because a lot of people don't understand this task. So I'm losing about 150 observations. the Kolmogorov-Smirnov tests actually deliver the same result. So it's the entire distribution which is moving to the left. And probably unsurprising, this is not driven by belief updating. So the interaction effect is completely insignificant. And actually, if I just use a dummy for whether people updated or not, it's become incredibly, like it goes to -19. So it looks like it's not driven by belief updating. It seems like it's the people who don't update it too. So at this point, I was swamped. I didn't know what was happening. So I talked with my friend who's doing experimental economics, and he studies belief updating in very controlled experiments. And I told him, what is happening? And he told me that probably it's just belief misreporting. And this is not very far-fetched. So this happens all the time in the experimental economics literature, that people can't really understand how to report their belief updating process. I'm not fully convinced, and I have two crucial slides where I will also try to convince you that there's something else going on. Just to recap, what does this treatment does? Two things. So it changes what information is acquired. So the people who are updating, they have different information, but also how information is acquired. And then there could be an effect where, because you were asked to read the text and you didn't choose to read it spontaneously, you could interpret this information differently. And I see that there's one group of people that, let's say, their entire learning process is different from baseline, when there's pure self-selection to this profile treatment arm, and it's the people in the highest risk category. So I see that they tend to fail the attention check, because I'm also asking this text comprehension question after the text they're asked to read. So they fail far more than the other group, than the other less at risk group. So actually, maybe I should have said that the passing rate is 1 in 4 for the sample, but for them, it's 1 in 2 for the sample, but for them it's 1 in 4. So this is more. They're more likely not to update compared to control, even if mechanically they read more, they have better information, and they're more likely not to update. And also they're more likely to report zero willingness to pay for insurance compared to control. So these are not the people that should, get out of this hypothetical insurance market. And yet that's what they do. But also I got mail. So this is not representative of all the survey comments and all the emails that I got. There was also a lot of good job, very useful. But I also got some angry emails in Dutch. I don't wish it upon any of you. So I would say there's two themes here. So one is really distrust towards information. Flood risk is all emotion and fear mongering by the media. Also, I do not attach much value to the information because they're different from my personal experience. And I know where this woman lives. I know it's a bit stalkerish, but I wanted to see where she lives, and it's close to a very small river. So then it makes sense that the information quality is not that high because they're very difficult to model. So then the information that I'm giving them is probably pretty noise. But then also, of course, distrusting insurance companies, that they're always looking for a reason not to pay out. But then a second thing is really, they know that they made a bad investment. So I think that they really feel left behind. So our building is no longer worth anything. That was supposed to be my pension. You're putting a standard on it. No one wants to buy. And now it's all about self-reliance, and you want me to buy insurance. So to conclude, I would say there's two main takeaways. So one is that offering information does not necessarily lead to convergent beliefs because the learning process is very heterogeneous in practice. But also visibility of information matters. Although in this context, I would say that the role of belief updating at best is unclear. And actually there's other potential mechanisms, for instance, backlash to information, emphasizing personal responsibility, distrust, aversion to insurance companies, and these are all consistent with this notion that adaptation to climate change is also shaped by social contracts. And that's everything I have for you today. Thank you.